This is Properties of Radicals Part 2. Today we're going to talk about rationalizing the denominator. To eliminate a radical from a denominator, when we're trying to simplify our radical, we can multiply by a fraction that is equal to 1. So here I have 2 over the square root of 3. To rationalize this denominator, to get rid of the radical in the denominator, I can multiply by square root of 3 over square root of 3. This fraction here is equal to 1. When I multiply my numerators, I get 2 square root 3. When I multiply my denominators, I get square root of 9, which can be solved because now this is a perfect square. So I get 2 square root 3 over 3. This is a simplified radical. There is no radical sign in my denominator. So I can use rationalizing the denominator to get rid of a radical in my denominator. Conjugates are binomials where we have a square root b plus c square root d, and its conjugate is a square root b minus c square root d, where a, b, and c all have to be rational numbers. Now we can also use conjugates to rationalize our denominator, because if I multiply two conjugates, I'm actually going to get this first term squared minus my second term squared. And by squaring those terms, I'm going to get rid of those radicals. Like radicals are radicals with the same index and the same radicand. Now remember, here's your index. In this case, since I'm doing a square root, it's 2. It could be a cube root, something like that. And my radicand here is 7. So these guys are like radicals. When we have like radicals, we can add or subtract them just like we combine like terms. So I have 5 square root 7 and 8 square root 7. So 5 plus 8 gives me 13 times square root 7. So let's take a look at a few radicals that we want to simplify, and we're going to use this new method, rationalizing the denominator. So in this first problem, square root of 5 over square root of 3n, I want to get rid of the square root of 3n in my denominator. So I'm going to multiply by a fraction equivalent to 1. I'm going to do square root of 3n over square root of 3n. And as long as my numerator and denominator are the same, it's equal to 1. So on the top here, that's going to give me square root of 15n. And on the bottom, it's going to give me the square root of 9n squared. So 15 and n can't be simplified any further. Neither of them are perfect squares. But I can break down my 9 and my n squared, both of which are perfect squares. And now I get, in my numerator, square root of 15n over 3n. This is a simplified radical because I do not have a radical sign in my denominator. Here we have a cube root. It's the cube root of 9. Now 9 is not a perfect cube. So I'm trying to think of something that is a perfect cube. Well, 8's a perfect cube, but we're already at 9. The next perfect cube is 3 times 3 times 3, or 27. So I want to get rid of this cube root by finding a perfect cube. So if I multiply by the cube root of 3 over the cube root of 3, I'm going to get 2 cube root 3 on top, and I'm going to get the cube root of 9 times 3, or 27, in my denominator. So now I'm going to have 2 cube root 3 on top over 3, because the cube root of 27 is 3. Let's take a look at a couple problems where we're going to rationalize our denominator using conjugates. So a conjugate is basically kind of like an opposite of this denominator, so that I can cancel out these radicals. So 2 minus the square root of 3. The conjugate here would be 2 plus the square root of 3. Now the reason that I'm using this is because When I multiply these two binomials, and they're exactly the same except one is plus and one is minus, my shortcut is I'm basically squaring the first term minus the square of the second term. So basically, here in my denominator, I'm going to get 4 minus 3. On top, I'm going to distribute my 7, and I'm going to get 14 plus 7 square root 3. 4 minus 3 is going to give me 1. So this is all going to be over 1. And anything divided by 1 is just that number. So 14 plus 7 square root 3 is my simplified new radical. So here my conjugate would be square root of 2 minus square root of 7. So I'm going to do that to the top and bottom. I have to make sure it's equal to 1, which on top I'm going to get 12 times the square root of 2 minus the square root of 7. And on the bottom here, it's going to be my first term squared minus my second term squared. So I'm going to get 12 square root 2 minus 12 square root 7. I get that from distributing my 12. And in my denominator, I'm going to have 2 minus 7. So I'm going to get 12 square root 2 minus 12 square root 7 over negative 5. And I can put my negative here, or I like to put it out front. So it's negative 12 times the square root of 2 minus 12 times the square root of 7 over 5. For this last problem, let's look at a real life problem. So the distance d in miles that you can see to the horizon with your eye at level h feet above the water is given by the equation d equals the square root of 3h divided by 2. They want to know how far can you see when your eye level is 5 feet above water. So the 5 feet above water is going to be my h. So I'm going to plug in 5 in the place of h. So I'm going to get the square root of 15 divided by 2. Now to rationalize my denominator here, I'm going to multiply the top and the bottom by the square root of 2. So I'm going to get the square root of 30 on top over the square root of 4 on the bottom, which is the square root of 30 over 2 miles. Now, this answer, even though it is a simplified radical, doesn't make much sense. So in my calculator, I'm going to do the square root of 30 divided by 2, and I get a long number, but it is approximately 2.74 miles. So I can see for about 2.74 miles.